In this video, I'll be going over control flow using the if statement. If statements can be used to add logic to programs and determine which line of code will execute next. When running a program, code is executed line by line. Actions are performed and the control flow may change. Specific conditions can change this control. For example, if, else, and else if. Let's take a look at a simple control flow. On the left, we have a flowchart, and on the right, we have some Rust code. In this example, control is linear and doesn't branch off. To begin, we start with the program. We have a variable named a, which we set equal to 1. We then have a variable named b, set to 2, and a variable named c, set to 3. After that's completed, the program ends. Translated to code, we have let some variable named a, we assign the value of 1, and we repeat the process with b and with c. Now we're going to introduce some logic. We'll start with the flowchart on the left. So the program begins, and we assign the value of 99 to a. We then go down here to the diamond. Diamonds in diagrams usually indicate that a decision is being made. Here, we're checking to see if a is greater than 99. If it's not greater than 99, we're going to print out small number. And if it is greater than 99, we're going to print out big number. In both cases, we're going to end the program after a message has been printed. So let's see how this translates into code. First, we create a variable named a and set it to the value of 99. Next, we perform what's called an if statement. So an if statement goes something like this. We use the keyword if and then have a condition. The condition evaluates to either true or false. If it's true, this first portion will be executed. If it's false, the second portion will be executed. You can see that these portions are enclosed within curly braces. And we also have this else keyword in between. If some condition is true, do this. Otherwise, do this. In our example, if a is greater than 99, we're going to print out big number, just as indicated by the flowchart. Otherwise, we're going to print out small number, just as indicated here. Now we're going to take a look at a nested if-else statement. We'll start with the diagram on the left. The program begins, and we set the variable a equal to 99. We then check to see if a is greater than 99. If so, we perform another check to see if a is greater than 200. And if it is, we print huge number. If it is not, we print big number. Either case results in the program ending. If a is not greater than 99, we'll simply print small number and end the program. Now let's see how that translates to code. First, we set the variable a to 99. Then we have our check. Is a greater than 99? That's represented by this code. As the previous example, we have if some condition is true, we will then enter this block of code. In this case, we're checking to see if a is greater than 99. And if it is, we'll perform another check here. And we'll see, is a greater than 200? If so, we enter this block of code here, and we'll print huge number. If it's not greater than 200, and this evaluates to false, control will then go to this else statement, and we'll execute the code here, print big number. If the first if statement evaluates to false, where a is not greater than 99, control will go to this else statement, enter into this block here, and print out small number. Let's take a look at another program that uses the same flowchart, but slightly different code. We'll be using the if-else statement instead of just nesting if statements. Before we get started, let's talk real quick about how else-if statements work. So first we have an if statement, and a condition is checked. If that condition evaluates to false, then the next else-if statement will be checked. If this condition is also false, then the next one will be checked, and the next, all the way until you end up at the else statement, in which case it will be executed, assuming all the other checks failed. When evaluating these statements, if either one of these evaluates to true, as usual, the inner part will be executed, and then once execution is complete, it will then jump out of this else block in both cases, and this will never be executed. So let's see how that actually works when we're using the flowchart. First, we'll set A to 99. Then immediately our flowchart diverges from our code. As we can see, in our flowchart, we check 99 first and then 200. However, in our else-if statements, we check 200 first and then 99. So why do we do that? If we take a look here at the bottom, where it's commented this will not work, let's see what happens if we use the same order as the flowchart. So let's say we have a number 100. And we check to see if it's greater than 99, and it is. So then big number will print. After that, flow will then be redirected to outside the if-else chain. However, if we have a number that, let's say 300, 300 is greater than 99. So it's still going to print big number, and then it will exit the if chain. But as we can see, we want to print huge number if it's greater than 300. So we need to check the largest number first, and then check lesser numbers subsequently, which is what we're doing here in the original code. So this will not work as intended. So first, we check to see if A is greater than 200. If so, we'll print out huge number. Control would then end up here if the statement evaluated to false. If A is not greater than 200, we then go to this else if, and we check to see, okay, is A greater than 99? And if it is, we'll print out big number and then exits the block. If A is still not bigger than 99, then we just go down here to the else statement, which will take all cases regardless of the number size, and it'll print out small number. To recap, code executes line by line. This can be changed using the if statement. Try to always include else statements unless there truly is no alternative case. You want to do this, that way all cases are covered and you don't end up in a situation where you're missing a case and your program doesn't behave as expected.